Today I want to look at quadratic graphs. Now these come in the form y equals x squared, or some variation of that. But the important thing is the highest power of x is x squared. And they produce a graph called a parabola. One way of doing it is using the table form, which we're used to. So when x is negative 3, y is negative 3 squared, which is 9. When x is negative 2, y is negative 2 squared, which is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared, 2 squared is 4, and 3 squared of 9. Now, looking at this table, we see there's a certain amount of symmetry, and it's symmetrical about the point x equals 0. We also see that all the y values are going to be greater than or equal to 0, which makes sense because any negative number squared is positive. And while we're talking about x and y values, we'll just define a few things. The domain, if you're asked or given a domain of a graph, it's the set of possible x values. And the range is going to be the set of possible y values. So looking at the table for y equals x squared, although we've used a domain of negative 3 to 3, x could be any possible value. Okay, so x could be any real number, which we can write as x is a member of the set of real numbers, and that's your domain. But y, however, as we said before, has got to be greater than or equal to 0. Greater than or equal to 0. Okay? It cannot be negative. And that's your range. Now the way I remember which one's which out of domain and range is D comes before R in the alphabet, and X comes before Y. Therefore X is the domain and Y is the range. Now if we were to plot the graph y equals x squared, it would come out looking like this. Now the important thing here is to look at some key points. This point here, this is called the vertex or turning point. Or turning point. Now on a standard y equals x squared graph, that's at the point 0, 0. The next thing to look at is the symmetry, and we can see here the symmetry is down this line. Okay, so the line of symmetry is the line x equals 0. That's your line of symmetry. Now plotting a graph, I know we can do it from the table, but another thing we can do is from the vertex, if you go out 1, you go up 1, because 1 squared is 1, and similarly on the other side, out 1, up 1. Then we can go out 2, and 2 squared is 4, so we're going to go up 4. Same on the other side, out 2, because minus 2 squared is 4, we go up 4. Same here, out 3, 3 squared is 9, so we're going to go up 9. and the same on the other side because of the symmetry. Out 3, up 9. So from the vertex we can draw any parabola using that rule. Out 1, up 1, out 2, up 4, out 3, up 9. Now I want to look at some of the transformations of the parabola. So we'll start with the form y equals ax squared. So if we change a, which can be any number, how does that affect the parabola? So remember, this is our normal y equals x squared, where we go out 1, up 1 on both sides, out 2, up 4, out 3, up 9. So what would happen if we were going to change this to y equals 2x squared? What would happen? Now here's the graph y equals 2x squared, and as you can see the graph seems to have got narrower or steeper. So a equals 2 is steeper. Now let's have a look at another one, y equals 3x squared. And if we draw y equals 3x squared, we can see it's even steeper. So what would happen if we wanted to draw y equals a half x squared? We can see here that the graph y equals a half x squared is wider. So as a goes up, it gets steeper. As a goes down from 1, it gets wider. What happens if a is negative? So let's have a look at y equals negative x squared, or negative 1x squared. You can see here when y equals negative x squared, it turns the graph, it flips it, so it now becomes upside down. So what does this mean to a? So if we have y equals a x squared, first of all we know that if a is positive, we're happy, so we get a smiley face. So it's in that shape. If a is negative, we're sad. If we're negative, we're sad. So we've got a sad face. And as a increases, the graph gets steeper. And as a decreases, the graph goes less steep or gets wider. So how does that help us with drawing the graphs? Well, we know y equals x squared. We know that the vertex is at 0, 0. And we know from the vertex we go out 1, up 1 on both sides, out 2, up 4, because that's 2 squared on both sides, and then out 3, up 9, because that's 3 squared on both sides, and so on. And then we draw a nice supposedly smooth curve through them. So that's y equals x squared. So if we wanted to draw y equals 2x squared, we can do a similar thing. The vertex is still 0, 0. So we've still got a point there. But this time we're going out 1, and because it's 2x squared, we're going up 2 times 1. On both sides. And then we're going out 2, and instead of going up 4, it's 2 times 4. So now we're going up to 8. on both sides. And when you've got all the points that will fit on the scale you've got, drawing a nice smooth curve with arrows at the end. How about if we wanted to draw y equals a half x squared? The vertex is still 0, 0, so we still start there, but this time we're going to go out 1 and up a half times 1 on both sides, and normally we'd go out 2 and up 4, but it's going to be a half of 4 on both sides. Then we'd go out 3 up 9, because it's a half x squared, it's a half of 9. And we'd go out 4 up 4 squared, which is 16, because it's a half of x squared, it's a half of 16, which is 8 on both sides if it fits. And then we can draw